Okay, welcome back to the tutoring session involving Ashley Johnson's fabulous worksheet. So what we're looking at here is we're using now chemical equations to solve problems. So how many moles of calcium sulfate would be produced if we were to have 1.8 moles of this calcium phosphate in the following reaction. So what we have to look at is the ratio of calcium phosphate to calcium sulfate. And we can clearly see that there is 1 mole of calcium phosphate would produce 3 moles of calcium sulfate. So in this case, because they're just asking for moles, and you're going from moles of one substance to moles of another substance, we don't need to look at molar masses or any of that nonsense. All we have to do is use our balanced chemical equation in order to solve this problem. So we start with what is given, 1.80 moles of calcium phosphate. And you're going to relate, that's right, moles of calcium phosphate let me not write the formula wrong, 2 moles of calcium sulfate. What is the ratio? It is 1 mole of this equals 3 moles of that. So it's 1.80 times 3, and I think the answer is something like 5.4 moles of calcium sulfate, but check that in your calculator. But it's 1.80 times 3. All right, so then we go to the next problem. We want to now know how many grams of aluminum bromide would be produced by reacting 2.90 moles of bromine, molecular bromine, in the following reaction. In this case, even though it's not said, you're going to kind of assume that this is excess. All right. And you can assume that this is our limiting reagent. So we want to know if we have 2.90 moles of this, which is almost 3, how many grams of aluminum bromide? So we're going to be just shy, if we look at the ratio, if we're just shy of 3 moles, we're going to be just shy of 2 moles. But we're going to do this in a stepwise process. So we have 2.90 moles of Br2. And because we're already in moles, we don't have to look at grams or anything. We can just use our balanced chemical equation. And we can go from moles of Br2 to moles of aluminum bromide. And we see the ratio is a 3-to-2 ratio. So 3 of these to 2 of those. But that doesn't quite answer our question because we want to know what is the mass of aluminum bromide that would be produced. So we need to now convert moles of aluminum bromide to grams of aluminum bromide. And we simply find the molar mass, and I'm just going to provide that. So it's 1 mole is equal to 267 grams. So plug that in your calculator, and we get something like should get something like 516.2 grams of aluminum bromide. Moving on to the next one. How many grams of silver are needed to react with 75 grams of S8 in the following reaction? Now we're looking at the ratio here, but we are in mass on both, so we have to know the molar mass of both. And what this is really telling us is, or we're trying to find is, if we have 75 grams of this, I only want to use the amount of silver that would react completely with this so that we don't have anything excess. So you're limited by both in this case, so that, or you can say they're stoichiometrically equivalent. So we have 75 grams of the S8, and we start with that because that's what's given. And we have to go from grams of S8. What is our next step? We have to be able to use this balanced chemical equation. What is this balanced chemical equation expressed in? That's right, moles. So we have to go to moles of S8. So right now we're just simply going from using the molar mass to take us from mass to moles. Now we're going to go from moles of S8 but I need to relate moles of S8 to moles of silver. And how am I going to do that? That's right, balanced chemical equation. So just to kind of help us out, 256 grams of this is equal to 1 mole. Now we're going to use our ratio. 1 mole of S8 is equal to 16 moles of silver. But we need to know the mass of silver. So we're going to now take moles of silver, and we're going to convert that to grams of silver. And that will answer our question. And as we look back, we can make sure that all of these things cancel. These units cancel, and they do. Whoops, those two cancel. Moles of silver cancel. But 1 mole of silver has a molar mass of 108 grams. So we simply plug that in our calculator. 75 times 16 times 108, and we can divide by 256. And you should get something like 506.25 grams of silver. All right, going on to the next one, 506.25 grams of silver. Now, this asks what mass of ammonia is needed to react with 1.20 kilograms of this substance in the following reaction. So this one is a little bit different because it's expressed in kilograms, which is a unit of mass. Of course, our molar masses are expressed in grams. So we're just going to have to convert kilograms to grams, which is easy because you have a 1,000 grams for 1 kilogram. So that's the first step we're going to take, is we're going to go 1.20 kilograms of the C6H10O4, and we're going to say that we're going to say kilograms of C6H10O4 is equal to grams of the same substance, and so 1 is equal to 1,000, and then now we can use our molar mass, right? So the molar mass of this substance, and I'm just going to give this to us, is 194 grams of C6H10O4 is equal to 1 mole C6H10O4. Now we are in moles, and we can take moles of this and relate it to moles of the NH3 is what we're trying to find. So now moles of C6H10O4 to moles of NH3, and we can clearly see the ratio is 1 to 2, and that's not good enough yet because we need to know the mass. So we're just going to convert moles of NH3 to grams of NH3. And by taking the molar mass, we can find that NH3 has a molar mass of 17 grams or something really close to that. And so now we're in grams of NH3. We're done solving our problem. We just check and make sure everything cancels. Kilograms, kilograms, grams, and grams, moles, and moles, moles, and moles cancel. We're left moles of NH3. And plug this in your calculator. 1.2 times 1,000 times 2 times 17, and we can divide that by 194 if that's what I wrote, and you get something like 210 grams, 210.3 grams of NH3. Too easy. This one asks us how many moles of CH4 are needed to produce 5.20 moles of water. In this case, we're going from moles to moles. No need for molar mass. So this problem's a little simpler. Just use our ratio found in our balanced chemical equation. So our ratio between CH4 and water is 2 to 6. So we see that 2 moles of CH4 to 6 moles of water. This asks us to go kind of backwards, going from product to reactant. So we're going to start with what is given, 5.20 of water. And we want to have that much water, so how much of this is needed is essentially what we're asking. So if we started with the moles of water, we're going to continue with moles of water down here so that it cancels, and we're going to go to moles of CH4. So what is the ratio? 6 moles to 2 moles. And it's as simple as that. So we are done. We have done solved the problem. 5.2 times 2 divided by 6, and you should get 1.73 moles of CH4. Moving on to the next one. This one is telling us that if we have 100 grams of aluminum and react it with 400 grams of iron 2 nitrate, that's this substance right here, in the following reaction, what will be the limiting reactant? And then what is the theoretical yield of aluminum nitrate in this reaction? And because they gave this problem to us in grams, I'm going to assume that they want the theoretical yield expressed in grams as well, even though they didn't say so. If you express it in moles, technically you're super correct too. So, but because they express these in grams, we're going to express our answer in grams as well. So we have 100 grams of aluminum. We need to know, if we're trying to find out how much aluminum nitrate would be formed, we're going to want to relate these two numbers to aluminum nitrate. We can determine what the limiting reactant is which one of these, 100 grams of aluminum or 400 grams of iron 2 nitrate, will produce the least amount of aluminum nitrate. We could solve it using iron, but then we would have to go back and do this question again. So in solving problem number 1, we're going to use aluminum nitrate because it's going to answer number 2 for us. So we have 100 grams of aluminum, and we know the molar mass of aluminum is 27 grams, and that equals 1 mole. And now we're in aluminum, we can relate it to aluminum nitrate, right? So moles of aluminum to moles of aluminum nitrate. And the ratio is 2 to 2. That's very, very nice. Makes things easy. So we don't really have to plug that in the calculator because 2 divided by 2 is equal to 1. So now we just need to know the molar mass of aluminum nitrate. So moles of aluminum nitrate is equal to grams of aluminum nitrate. So 1 mole, and I'll give you the molar mass of aluminum nitrate. If I wrote it down, it should be somewhere around 213 grams. And so we simply take 100 times 213, and then you can divide by 27. And you should get 788.88. So 788.88 grams of aluminum nitrate. Does that answer the question? Absolutely not. We still have to figure out what mass of, if we have, what was the number here? 400 grams of the iron nitrate. We need to know, that's it, iron 2 nitrate or iron 3? Oh, it's iron 2 nitrate. I may have to get my molar mass changed on my paper here, so I'll make the adjustment on the fly. So if we take iron 2 nitrate, let me get the molar mass of that real quick. We have 14, 15, should be around 180 grams, and check that for yourself to make sure that's correct. So this is actually a 2. I thought it said iron 3 nitrate when I read this earlier, so I apologize for that, but that's the power of the fast forward button. FeNO32 is equal to 1 mole. 1 mole of FeNO32. Now we just have to relate that to moles of aluminum nitrate. So moles of FeNO32 to moles of aluminum nitrate. And the ratio is 3 to 2. And now express this back into grams. Moles of aluminum nitrate to grams of aluminum nitrate. And we already have that expressed up here. 1 mole is equal to 213 grams. So now we simply take 400 times 2 times 213, and then we can push divided by 180 equals divided by 3, and you should get something like 315.55 grams of aluminum nitrate. So we go back to our question. Which will be the limiting reactant? Which produces the least amount of the product being aluminum nitrate? That's going to be our iron 2 nitrate. It produces less aluminum nitrate. What is the theoretical yield? It's the lower number. So the theoretical yield is going to be 315.55 grams. So your limiting reactant, here's a clue. Limiting reactant is always a reactant. Don't get confused. Many people try to, when they say limiting reactant, they want to put this substance here. No, that's your product. Look over here. It is a product. It can't be a limiting reactant. A limiting reactant must be a reactant. It is either this or this. Those are only two choices, and they're reactants. So don't get confused on that. And then lastly, we have 85 grams of nitrogen monoxide, 50 grams of O2, and they are reacted to the following equation, which will be the limiting reactant, and then what will be the theoretical yield. In this case, you only have one product to use, so obviously it's going to be NO2. You don't have a choice, whereas in the last problem, you did have a choice, but since they were asking about aluminum nitrate, we chose aluminum nitrate. Here, you have one choice for a product. So which of these produces the least amount of product? So we're going to do the same process again. We're going to take 85 grams of nitrogen monoxide. We're going to convert that to moles. And then we're going to take moles of nitrogen monoxide. We're going to take that to moles of nitrogen dioxide. And then we're going to take moles of nitrogen dioxide to grams of nitrogen dioxide. And again, it says what is the theoretical yield? We could stop right here, express our answer in moles, but because they gave us grams in the problem, we're going to just express our answer in grams. So the molar mass of nitrogen monoxide is 30 grams, is equal to 1 mole, whereas our ratio here is 2 to 2, so we don't need to do too much work there. Those will cancel on our calculator. And then 1 mole is equal to 46 grams. So we just simply plug this in our calculator. 85 times 46 divided by 30, and we should get 130.33 grams of NO2. All right, and then the last one, 50 grams of oxygen. Convert this to moles, grams of O2. This is going to be 32 grams is equal to 1 mole of oxygen. Use the ratio, moles of oxygen to moles of NO2. 1 mole equals 2 moles. And then lastly, convert moles of NO2 to grams of NO2. So that is 1 mole is equal to, and we have it up here already, 46 grams. So we take 50 times 2 times 46 divided by 32, and we get 143.75 grams. And that was 130. So the question is, what is the limiting reactant? Which of these reactants, nitrogen monoxide or oxygen, produces the least amount of product, NO2? So our limiting reactant is nitrogen monoxide. Why? Because it produced 130 grams, whereas oxygen produced 143.75 grams of the nitrogen monoxide, or dioxide rather. So then what will be the theoretical yield? Theoretical yield, TY, is this right here, 130.33, because it is limited by the amount of nitrogen monoxide that you have in the problem. Thank you for watching.